Hi, I'm Karina. Here I'm going to share with you guys about the transition metal objective. They are two different kind. So the first one is to examine some of the solution chemistry of the transition elements, and the second one is to investigate the evidence of the complex formation and the change in oxidation state. In particular, which are two important general characteristics of the transition elements.
In this page, I will introduce transition metal and coordination compounds. First, transition metal are elements found in the D block of the periodic table, which is from group 3 to group 12. These elements have partially filled d orbital, which give them special properties. Because of this, transition metal can show different oxidation state from color compounds and also have catalytic and magnetic properties. Next, coordination compound are compounds that contain a central metal atom or metal ion surrounded by molecules or ion called ligands. These ligands donate electron pair to the metal to form coordinate covalent bonds. As a result, a stable structure called a complex is formed. These characteristics make transition metal and coordination compound very important in chemistry.
Hi and Assalamualaikum. My name is Nuramani Iman binti Hanizam Shah, and now let's discuss about transition metals. What is transition metals? Transition metals are elements that have partially filled d orbitals in their atoms or in their commonly formed ions. This special electron arrangement gives them unique properties compared to other metals. One of important characteristics of transition metals is that they can have variable oxidation states. For example, iron. Iron can exist as ferrum 2 plus and ferrum 3 plus, which allows it to take part in different chemical reactions. Moreover, transition metals also form colored compounds. This is why many solutions containing transition metal ions appear as blue, green, or yellow. Another key feature is their ability to form complex ions, where the metal ion bonds with molecules or ions called ligands. In addition, transition metals are a good catalyst. They are widely used in industries to speed up chemical reactions without being consumed. They also generally have high melting points and high densities, making them strong and durable materials. And lastly, the common examples of transition metals include iron, copper, and nickels, which are widely used in everyday life and industrial applications. Next, let's continue to learn about the coordination compounds. Coordination compounds are compounds that consist of a central metal ion bonded to surround the molecules or ions called ligands. These ligands attach to the metal ion through coordinate bonds, where both electrons in the bond are donated by the ligand. The general formula of the coordination compound is written as a complex ion followed by a counter ion, which can be either a cation or an anion. For example, on the slide I put the example of how to write a correct coordination compounds which contains complex ions and a chloride counter ions. And based on the example, the IUPAC name of the compound is pentaamine chlorocobalt in bracket 3 chloride. From this name, we can tell the number of ligands, the type of ligands, the metal involved, and its oxidation state. And lastly, coordination compounds are important because they are commonly found in chemical reactions, biological systems, and industrial applications. Last but not least, let's talk about ligands. Ligands are molecules or ions that bond to a central metal ion in a coordination compound. They attach to the metal by donating at least one unshared pair of valence electrons to form a coordinate bond. So, there are three types of ligands, which can be classified based on the number of donor atoms they use to bond with the metal ions. The first one is monodentate ligands, which bond through only one donor atom. Common examples include ammonia and water. For the second one is bidentate ligands, which bond through two donor atoms at the same time, which, for example, is ethylene diamine, which also known as EN. And the last one is polydentate ligands, which bond through more than two donor atoms, such as 4, 5, or even 6 donor atoms. A well-known example is EDTA, which can form very stable complex. These different types of ligands play an important role in determining the structure and the stability of coordination compounds.
So next, I'm going to explain about the reason why transition metal compounds are colored. So it is mainly because of electronic transition involving d orbitals. So here's the step-by-step explanation. So the first one is it is partially filled d orbital. So the transition metals usually have partially filled d orbital. So this is essential for color. Ions with completely filled or empty d orbitals are generally colorless. The second one is crystal field splitting. So when a transition metal ions forms a compound or complex, ligands surrounds the metal ion. Their electric fields cause the 5d orbital to split into two different energy levels. So the next one is absorption of visible light. So when visible light shines on the compound, electrons can absorb energy and move from a lower energy d orbital to a higher d orbital. So the next one is observed color is complementary. So the color seen is complementary to the color absorbed. So for example, if red light is absorbed, the compound appears either green or blue-green. The last one is factors affecting color. So the exact color depends on the metal ions and its oxidation state. So the type of ligand, either it is strong field or weak field ligands. And the geometry of the complex, which is octahedral, tetrahedral, or a square planar. So here's the real life application. So transition metals and their coordination compound have many important real life applications because of their variable oxidation state, ability to form complex, and catalytic properties. So the example is medicine and biology, catalysis in industry, materials and manufacturing, environmental and analytical applications, and the last one is technology and energy.
Hi, my name is Aisha. So for conclusion, the transition metals such as iron, copper and nickel shows a unique chemical behavior due to their partially filled d orbitals. These metals can exist in different oxidation states and easily form coordination compounds by bonding with ligands through coordinate covalent bonds. The formation of complex ion often results in colored compounds, which occur because of electronic transition between split d orbitals when visible light is absorbed. Transition metals also exhibit important properties such as catalytic activity, magnetism, and high melting points. These characteristics make transition metals and their coordination compounds highly valuable in many real-life applications, including medicine, industrial catalysis, material science, environmental analysis, and energy technology.
you.